Finally, we got to random number generation using NumPy. Even though we have used the random module of Python's standard library for creating random numbers, uh, default for random number generation really is using NumPy. The difference, big difference, is that random module of standard library, Python library, it's a part of Python. You don't need any other library for accessing that. It just comes with Python. However, uh, NumPy is a library created by a third party, and if you want to use NumPy for random number generation, you must make sure that it is installed. Fortunately, when you install Anaconda, NumPy comes pre-installed with it. All right. So let's see how it works with random number generation with NumPy. So I'm going to just type np. We have imported NumPy. Let me try it even import. It's fine. NumPy as np. So what we are doing here, we are making or importing, making available NumPy or importing NumPy as a library. It's a library, all right? And np dot, if I look for random and put question mark in front of it, it is going to say it's a module. So I'm using this as an opportunity to explain this. Inside one library, you can have multiple modules, all right? And every module is usually is done for a certain is used for a certain purpose. In this case, random module is used for generating random numbers. All right, let me see how far do I need to go. There we go. All right, so let me all the way down here. Np data random data. This is an older way of generating random numbers using NumPy. All right, I can call random function. All right, you see that there is a function in front of it, random function, and in front of every function you must have parentheses open and close. You can do this. This is possible. All right, if I run it one more time, I'm going to get a different random number, uniform random number between 0 and 1. All right, this is possible. This is the older way of generating random numbers. This is in a newer version. This is Python NumPy's suggestion. First, create an object or generator using this method. We are going to, it's very common to use RNG, random number generator, is equal to, RNG is equal to np data random. Let's access that capability of NumPy, random data default RNG. All right. Now you can pass parameters inside this. It doesn't really matter at this stage. Default RNG. First, I'm creating a generator. But what kind of random number is this generator going to generate? Well, I don't, it could be used for any kind of random number generation. So let's practice. RNG dot what do you want? From beta distribution, from gamma distribution? What do you want? Do you want from uniform distribution, triangular distribution? What do you want? So standard normal. So let's use standard normal. Standard normal, and let me put question mark in front of it. We know that it has mu of 0 and sigma of 1. Let's see if this function accepts any parameters. I hope you can guess that this is going to be one of the important parameters is going to be the size. All right. And sure enough, it is size. All right. I want to, let's say I want to create 6 standard normal random numbers from standard normal distribution. It is going to be data vector. All right. Now let me see how we can use this in combined with other capabilities that we have learned. We can use Reshape for this one. All right. Then you are going to have different shape, possibly matrix. Another way of doing same thing is RNG data that standard normal. Instead of providing 6, you can say, I want shape of 3 by 4. So now you are going to have 12 random numbers, but they are shaped in a matrix of 3 by 4. Now, I'm not going to go into details of all of these functions. It really is unnecessary. RNG data, you can create bunch of random numbers. And if you don't know which one is doing what or which one is what, for example, integers. I don't know what this one does. All right, so you can put question mark in front of it, and it is going to say you need to provide low, you need to provide high, size, and so on and so forth. All right, and the beauty of NumPy's and docstring is that it provides bunch of examples at the end. You can rely on those references. I personally, I never memorize these syntaxes because simply you can't, right? You don't use all of these functions in all packages all the time. It doesn't work like that. Whenever you need it, you can come back and just put one or two question marks in front of the function and figure out or recall what it does and use it for your purpose.